Hello friends, so in this video we are going to discuss the full subtractor implementation, again using basic logic gates but without XOR gate. Okay, so there will be no 3 input XOR gate used. Okay, without XOR. So here first we have to write the Boolean expressions. So this is the block diagram of full subtractor. 3 inputs, A, B, B in, difference, output, borrow. So here we'll write the difference as this variation, this one, A bar, B in, or A bar, B in bar, or A, B bar, B in bar, or A, B in. Okay, A bar, B in, A bar, B in bar, A, B bar, B in bar, A, B in, this. And for borrow, the expression stays the same. A bar B, or B in, or A bar B in. Okay, same as the previous case. So now here we have to use 4 3 input AND gates because there are 3 inputs which are in AND form. I always told you product means AND. And for this sum of products operation, these 3 min terms or product terms are ORed. So we have to use a 4 input OR gate to OR them together. And here we have to use 3 2 input AND gates and 1 3 input OR gate. Okay, here 1 input 4 gate and 4 3 input AND gates, here 3 2 input AND gates and 1 3 input OR gate. So let us see how we will do this. Okay. Okay, first let us take the input lines. So we have A, we have B, and we have B in. Let us take their complement, NOT gate, A bar, NOT gate, B bar, B in bar. So here we have to use what? 4 3 input AND gates. So this is the first, this is the second, this is the third, this is the fourth one. Okay, so in the first case, A bar, B in. So we'll take A bar, we'll take B bar, and we'll take B in. only B in. So we have A bar, B bar, B in. Okay. Then let's take out A bar, B, B in bar. Okay. Let's say the output of this gate is A bar, B, B in bar. So we have to give A bar, then B, then B in bar. Okay, A bar, B, B in bar. Let's say this one is A, B bar, B in bar. So we'll take A, we'll take B bar. This is B bar. This is B bar. Yes, B bar. Yes. So always be careful which line you take the input from, because there are a lot of input lines. It can get very confusing, very messy. So always, do it with focus. Okay, A, B bar, then B in bar. This is B in bar, B in bar. Yes, this one is B in bar. So A, B bar, B in bar, and then we have finally A, B, B in. So we'll take A, then we'll take B. This is B, and then we'll take B in. So we have A bar, B bar, B in, A bar, B, B in bar, A, B bar, B in bar, A, B, B in. Now we have to use a 4 input OR gate to OR them together. So this, 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 this. So finally the sum of these product terms, min terms. So this gives us the difference, D. A bar, B bar, B in, or A bar, B, B in bar, or A, B bar, B in bar, or A, B, B in. This is the difference. So we have used 4 3 input AND gates and 1 4 input OR gate. Now for the other, it is the same as the previous case. So let's do it. So we have to use 3 2 input AND gates. So let us identify the lines. So let us take the lines. Okay, A bar, B, B in. These are required. So let us take them, because when we'll push this canvas upwards, it may not be visible. So let's take the lines. This is A bar. We need A bar, so this is A bar, and we require B and B in. So B, this is B, and then we require B in. This is B in. Okay, A bar, B, Bn. The first one is A bar, second one is B, third one is Bn. Okay, this one. Okay, let's take it up to this watch. Okay. Now here what we have to do, we have to use 3 2 input AND gates. One, two, three. So A bar, B, then B, B in, this is B, B, B in, then A bar, B in. Okay, here. A bar, this is B in this one. Okay, this line is B in. So we have this A bar, B in. Okay, so A bar B, B, B in, A bar B in. So now we have to use a 3 input OR gate. So this is the output borrow, which is equal to A bar B or B, B in or A bar B in. So here we have got the difference, and here we have got the borrow. So here we have implemented the full subtractor using only basic logic gates without XOR. So in the first case, in the previous case, all this mess would have been avoided if you would have used a single 4 input XOR gate. So for that single 4 input XOR gate, we had to do all this. We had to use 4 3 input AND gates, then 1 4 input OR gate for that single 4 input XOR gate. So this entire thing represents that one 4 input XOR gate. Okay, so this is nothing but A XOR B XOR B in, isn't it? It's the same as that. This is nothing but A XOR B XOR B in. So in that case we used a single XOR gate, 3 input XOR gate. But here we had to use 4 3 input AND gates and a 4 input OR gate for that single 3 input XOR gate. And this is for the difference. The borrow remained the same. The design principle of borrow, it stays the same for whether it is with XOR or without XOR. Okay, so this is the thing. So let's look at the entire circuit diagram. See this is the thing. Yes.